Welcome to our video on solutions. Now a solution is a mixture, right? And we have two things in solution. We call one the solute and one the solvent. The solute is the thing being dissolved and the solvent is actually doing the dissolving. And the dissolving process is kind of interesting. I'm not going to draw it all out, but what you have is something that you put in water and it's highly attracted to water, so it's going to be pulled apart and surrounded by water molecules, all right? Which leads us to the idea of an electrolyte. Now, your concept of Gatorade might be a little grosser after you hear what an electrolyte is, but essentially what it does is it conducts electricity when dissolved in water, and usually these are ionic compounds or they are acids. All right? These are going to be our electrolytes. Non-electrolytes do not conduct electricity when dissolved in water. This is one main difference we have to talk about when things are being put in water. And what's important to understand is in order to conduct electricity, ions actually have to be formed. With no ions, then you can't conduct electricity. I am in no way suggesting you take your toaster into the bathtub, because the water coming out of your faucet has a lot of different ions dissolved in it, one of them being fluoride, which is put in the water to protect your teeth, all right? But if you had perfectly pure water, that will not conduct electricity because there are no ions in solution. So here we're going to talk about a couple things. Some of the rules you're going to see crop up later on, and you're just going to have to trust me on this one. But here are 8 examples. We're going to determine if they're electrolytes or non-electrolytes. This first one, C12H22O11, is actually sugar. This is a non-electrolyte. There are no ions formed when you put it in solution. When sugar dissolves, the sugar molecules, there's a lot of them, even in a very small grain of sugar, start to separate, and each sugar molecule is surrounded by a lot of different water particles. And so we're not generating any ions. You can put all the sugar in the world into a glass of water and it'll taste good, but it won't conduct electricity because there are no ions for it. Magnesium fluoride. This is an ionic compound, and when we put it into water, it's going to split up into its ions. So anything that splits up into ions is going to be an electrolyte. Now the question is, how many ions do I get from magnesium fluoride? Well, I get 1 Mg plus 2 ions. There's 1 ion. And how many F minus ions am I going to get? 2 F minus ions. So I get a grand total of 3 ions in solution. This is great. It's an electrolyte. Sodium chloride. Sodium chloride is going to behave very similarly to magnesium fluoride, except that we're going to have 1 sodium ion and 1 chlorine ion. This is an electrolyte. Silver chloride is going to work on a different level. Silver chloride is actually an insoluble compound, which means it will not dissolve in water. If it doesn't dissolve, then it's not going to generate ions. If it doesn't generate ions, this is considered a non-electrolyte. These two over here they're not special cases, but they come back to what will actually form or what we consider electrolytes. We've talked about a couple ionic compounds that are electrolytes, but we haven't talked about acids. This is a discussion in amongst it by itself. But these two, hydrochloric acid and hydrofluoric acid, these are both electrolytes. One of the things about acids, or the definition of an acid, is that it adds H plus to solution. So if you put hydrofluoric acid in solution, it splits into H plus and F minus. You're generating ions. For the last two, calcium carbonate, it's what's in marble. Marble does not dissolve in water. So this is a non-electrolyte. And sodium hydroxide is probably the most used base in the world. Sodium hydroxide is an ionic compound, as you should know, and it splits up in the Na plus and OH minus ion. So this, too, is an electrolyte. Hopefully this gives you a good idea about what is an electrolyte and what is a non-electrolyte, and we're going to delve into a lot of different things as we move forward.